In this video, I'll show you how to find the curl and the divergence of the vector field F here. Let's do the curl first. So by definition, we will do the del and the cross product with our vector field F. Remember, curl and cross product, they both start with a C. So that's how I like to remember it. And for the cross product, we will get a 3 by 3 matrix and then do the determinant. The first row is just going to be the I, J, K unit vectors. And then the second row is just the operators, partial with respect to X, with respect to Y, and with respect to Z. And lastly, we'll put down the components expression. So this right here, 2x third power plus y squared, and then x, y, z third power, lastly, x squared z. Now, you have two choices to do the 3 by 3 determinant. You can write down 2 more columns right here and then do all that. But in my opinion, that will be too hard for this case. I think it's easier if you just kind of do the cofactor expansion and then kind of remember what to do. I think that's the best. Let me demonstrate. To do the cofactor expansion, use this, meaning delete this, delete that. Look at this and then do the 2 by 2 determinant. So first you do this times that by really taking the derivative of this expression with respect to y, but there's no y, so just get 0. And then you subtract this times that, take the partial of this with respect to z. Here we have z to the third power, so we get 3 and then x, y stays, and then z squared. This will be with the I component, right? So with the I. And then going to the j, remember plus, minus, plus. So this right here will be a minus for the j. So let me just write this down. Positive, negative, positive. And then negative, positive, negative, and all that stuff, right? But anyways, minus. You are going to delete this, delete that. So you're looking at this and that. 2 by 2 matrix. So we do this times that. Take the partial of this with respect to x. So put the 2 to the front and then x, z. Minus this and that. But there's no z, so this is going to be 0. And that will give us the j component. Lastly, for the k, that's again another positive, and then delete this and that. Partial with respect to x, we just have this y, z to the third power minus this and that. This right here has no y, so it's 0. And then the partial of that is 2y. That's it. And here is the k component. And then that's pretty much it. You can probably write it down nicely, getting rid of the 0, but there's nothing to combine because they are 3 separate components. So for this, I'm just going to write down the final answer right here for you guys. For the curl, the first component is this, negative 3x y z squared. The second component is negative 2x z. And lastly, we have this right here, which is y z to the third power minus 2y. So that's the curl. Now, the divergence. So by definition, divergence is the del with the dot product and then the vector field. So in this case, what we'll be doing is that the del is this vector, partial with respect to x, with respect to y, with respect to z. And remember, this right here are just the operators. And then we're dotting with these components right here, right? This vector field, so 2x third power plus y squared, x, y, z third power, x squared, z. Okay. For the dot product, you just do multiplication component-wise. But this times that is really, look at this expression and take the partial with respect to x. So do just that. Then in that case, you get 6x squared. This is y squared, which is like a constant, doesn't matter. And then remember, we have going to add this and that. So we take the derivative of this with respect to y. Just get 1. So we have x z to the third power. And lastly, this and that. Here we have just 1 for the z. So plus x squared. Now for this right here, notice there are just 3 separate expressions and you can add them up, right? And this and that, which you will get 7x squared, and then this right here stays. So for the divergence, we just get 7x squared plus xz to the third power. So yeah, this is the curl, this is the divergence.